Hi guys, this is organic nomenclature and we are going to be naming alkenes. Now, the general formula of alkenes has a double bond present as the functional group between two carbon atoms. So, this is the basic way in which we can write alkenes, and it has got a formula of CnH2n, which means the number of hydrogen atoms present in the molecular formula of the alkenes is twice the number of carbon atoms present in it. So, the simplest alkene would be the one having only two carbon atoms, which would be CH2 and CH2. And instead of a single bond, we would have a double bond here, and the name of this compound would be ethene. So now we have introduction of a functional group here. So the rule becomes give the least number to the functional group, followed by giving the least number to the substitute group. If we have a choice between giving the least number to the substitute group and the least number to the functional group, we will always give the least number to the substituted group. No, 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 no. We will give the least number to the functional group. Substitute group's preference is lesser than the preference of the functional group. So the least number of the functional group is the preferred way. So in order to name alkenes, we have ethene, propene, butene, pentene, hexene, heptene, octene, nonene, and decene. However, the name changes based on where the double bond is placed. So, in order to name alkenes, we would consider the position of the double bond. So, the number of carbon atoms in which the position of double bond can vary starts with four carbon atoms. So, we've got one, two, three, and four. Now, the positions here would be either we have a double bond here or we have a double bond placed here. So the name of these compound now I have not written the hydrogen atoms on these compounds which can be completed later because the position of the double bond is the one under consideration here. So in order to name these compounds, we would number them giving the least number to the substitute group, which would be 1, 2, 3, 4 in this case. And since there are four carbon atoms, the parent compound would be butene, but showing that the position of the double bond is between the first and the second carbon atom, the name of the compound becomes but 1 ene. And in the second case, now we'll have to check the numbering of the carbon atoms based on the position of the double bond. So numbering from left to right, 1, 2, 3, 4. We have got the double bond present between the second and the third carbon atom. Numbering it from right to left, 1, 2, 3, and 4. We've got the double bond present between the second and the third carbon atom. So the numbering in this case is irrelevant, whichever direction we prefer, because the position of the double bond is between the second and the third carbon atom. So the name of this compound becomes but2ene. Next, we will check for the choice between the position of the double bond and a substitute group. So we've got C, 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 and C here. Now the position of the double bond is placed here, whereas we have a substitute group placed over here. One more thing we need to remember is if we had placed the substitute group on the carbon atom on the extreme right, then that would not be called a substitute group, as adding a carbon atom to a terminal carbon atom only increases the length of the carbon chain. So instead of this compound being butene, it would have become pentane. So we need to remember that. So here again, I am not including the hydrogen atoms in the parent compound, just the hydrogen atoms in the substitute group, because we already know that the parent compound would have hydrogen atoms present nonetheless. So now, in order to check for the numbering, we have the numbering going from left to right, 1, 2, 3, 4, and from right to left as 1, 2, 3, 4. So obviously the preference is given to the functional group. So the name of this compound would have the methyl group present on the third carbon atom. So the name becomes 3 methyl, and the position of the double bond is on the between the first and the second, so 1 would be the position of the double bond, and 4 carbon atoms are present, so the name becomes but 1 ene. Similarly, if we had placed the double bond between the second and the third carbon atom, so this would be 1, 2, 3, and 4, and CH3 here. Now, in this case, the numbering from left to right would be 1, 2, 3, and 4, and the numbering from right to left would be 1, 2, 3, and 4. Now, here, this is a tricky situation. We've got the carbon atom on the second and between the second and the third, the double bond between the second and the third carbon atom. However, if we number it from left to right, we've got the methyl group on the third carbon atom. But if we number it from right to left, the methyl group becomes placed on the second carbon atom and the double bond remains on the second carbon atom. So the correct naming would be when we number this change from right to left. So the name becomes 2 methyl and but 2-ene. So we need to be careful when we have such a situation present in the given organic compound. Considering another alkene, we have multiple substitutions on the alkene molecule. So now we would have 1, 2, 3, 4, and 5 carbon atoms in a straight chain. We would have a double bond placed here. We would have a substitute group placed here, methyl, and here as methyl again. So in order to number this compound, we already know that if we are giving preference to the double bond, then the numbering is only done from left to right. So 1, 2, 3, 4, 5, in which case the name of this compound becomes 2, comma 2 dimethyl, because the substitute groups are placed on the second and the fourth carbon atom, and the double bond is placed on the second carbon atom. So the name of this compound becomes 2, 2 dimethyl pent 2-ene. If we have the same compound, but the position of the double bond changes, if we have it on the third carbon atom from the left, so 1, 2, 3, 4, and 5. And we have got placement of the methyl groups exactly where they were, CH3 and CH3. Here, the numbering would change because if we number it from left to right, the position of the double bond lies on the third carbon atom. However, if we number it from right to left, 1, 2, 3, 4, and 5. So the position of the double bond stays at the second position, and basically this is the same compound as the first one, which was wrongly numbered as 2 comma 2. It is supposed to be 2 comma 4 because the second methyl group is on the fourth position. So here again we've got the first methyl group on the second carbon atom and the second methyl group on the fourth carbon atom. So the name of this compound remains 2 comma 4 dimethyl pent 2-ene. In other words, the compound drawn right now and the compound drawn before are the same compound, just inverted. So they are exactly the same compounds. Another alkene would be 1, 2, 3, 4, 5, 6, having 6 carbon atoms with a double bond right in between. So the numbering would not matter if we have to just number this compound. However, the numbering would now depend on where we have which substitute group present. So in order to place the substitute groups, I am placing a methyl group here and an ethyl group here. So the number of carbon atoms in the straight chain is 6, and the number of carbon atoms in the chain that bends at ethyl is also 6. So we let the straight chain be the parent compound. So now the numbering here will matter, because if you number it from left to right, 1, 2, 3, 4, 5, and 6, we've got the methyl group present on the third carbon atom and the ethyl group present on the fourth carbon atom. However, if we number it from right to left, 1, 2, 3, 4, 5, and 6, we would have the ethyl group on the third carbon atom and the methyl group on the fourth carbon atom. Double bonds position remains the same at the third carbon atom. So the numbering from right to left would be preferred, because we would give the least number to the substitute group that comes alphabetically first. So the name of this compound becomes 3-ethyl 4-methyl hex 3-ene. Another alkene has this structure, C double bond C, with each positions on both the carbon atoms having a CH3 group attached to it. So here the numbering would be done with the parent compound having the longest carbon chain, which would be starting from here 1, 2, 3, and 4, or and checking for the positions of the substitute group 1, 2, 3, 4, which does not matter because the substitute groups are on the second and the third carbon atoms. So the name of this compound becomes 2, 3 dimethyl butene. However, if we have a change in the length of the carbon group, so this would become CH3, C double bond C, then we have got CH2, and then we've got CH3. Now the naming would be changed, because here, if we number it from left to right, the name would become 1, 2, 3, 4, and 5. This would be the parent chain, and the name would become pent-2-ene instead of butene. But the numbering would remain in this way because we have to give the least number to the double bond, and the double bond in the numbering that we have done has the second and the third carbon atom as the placement of the double bond. So the number in the written would be 2. So the name of this compound would become 2, 3 dimethyl pent 2 ene, 2 3 dimethyl pent 2-ene. What if we change the CH3 group present on the third carbon atom into an ethyl group? Let's see what the naming then becomes. So we would have this compound written as CH3, C, CH3. Then we have a double bond. Then we've got a C with CH2 and CH3 written here, and a CH2 and a CH3 written here. So the name of this compound, numbering would remain the same because the position of the double bond is the one that is given importance. So 1, 2, 3, 4, 5. However, now we've got a methyl group on the second carbon atom and an ethyl group on the third carbon atom. So the name of this compound would become 3-ethyl, because alphabetical preference has to be given to the naming of the compound. So ethyl E comes before the M of methyl. So 3-ethyl, 2-methyl pent 2-ene.